The moon that should not be alive. What if the most important ocean in the solar system is not on Earth, not under our blue sky, not beneath sunlight, not touching any beach, but hidden far away, under a frozen shell, beside the most powerful planet in our solar system? And if that ocean is alive, then everything we believe about life may be wrong. There is a moon near Jupiter that looks completely dead. Its name is Europa. Love space, science, and cosmic mysteries? Subscribe to the Cosmic Earth and join the adventure. Europa does not look like a living world. It has no forests, no rivers, no clouds, no blue surface oceans, no warm sunlight falling on land. From the outside, it looks like a frozen stone, a silent white moon moving through darkness. But that is what makes Europa so dangerous to ignore, because sometimes the most important worlds do not look important at all. Europa orbits Jupiter, and Jupiter is not just another planet, it is a giant, so massive that more than 1,000 Earths could fit inside it. Its gravity controls everything around it. Its magnetic field is enormous. Its radiation belts are deadly. Around Jupiter, moons do not simply orbit. They survive inside the kingdom of a monster, and Europa is trapped there. Small, frozen, bright, silent. But when scientists looked closer, Europa stopped looking simple. Its icy surface was not smooth and clean. It was covered in cracks. Long, dark lines stretched across the moon like scars. Some regions looked broken. Some looked shifted. Some looked as if the ice had opened, moved, and frozen again. And that raised a question no one could ignore. Why does a frozen moon look active? Europa should have been an old, dead world. Cold forever, frozen forever, still forever, but its surface looked young, changed, disturbed, almost alive in its own way. And then the mystery became even deeper. Scientists began to suspect that beneath Europa's ice there may be water, not a small lake, not a temporary melt pocket, but a global ocean, a dark ocean covering the entire moon beneath its frozen surface. An ocean that may contain more water than all the oceans on Earth combined. That single possibility changes Europa from a dead moon into one of the most important places humanity has ever studied. Because on Earth, water is not just water. Water is where life hides, where life begins, where life survives. We find life in boiling springs, in frozen lakes, inside dark caves, under rocks, deep below the ocean, even near volcanic vents where sunlight never reaches. Earth keeps teaching us the same lesson. Life is harder to kill than we once believed. So when we look at Europa, the question becomes terrifyingly simple. If Earth's life can survive in darkness, could Europa's ocean be alive too? This does not mean fish. It does not mean alien cities. It does not mean glowing creatures swimming under the ice. The first life we might imagine there is much smaller. Microbes, tiny cells, simple organisms using chemistry instead of sunlight. But even one living cell beneath Europa's ice would change human history forever. Because it would mean life did not happen only once. It would mean Earth is not special in the way we thought. It would mean the universe may know how to make life again and again. And that possibility is why Europa feels almost frightening. It looks dead, but it may be hiding the answer to one of the oldest questions humans have ever asked. Are we alone? For a long time, humanity searched for life by searching for another Earth, a planet with sunlight, air, oceans, clouds, warm land, a familiar sky. That made sense. Earth is the only living world we know, so we looked for worlds that looked like Earth. But Europa forces a different idea into our minds. Maybe life does not need an open sky. Maybe life does not need sunlight. Maybe life does not even need a planet. Maybe life can begin under ice, in total darkness, on a moon orbiting a giant planet. And if that is true, then the search for life becomes much bigger, because Europa is not alone. Saturn's moon Enceladus shoots water vapor into space. Titan may hide water beneath its strange surface. Distant icy worlds may also contain buried oceans. The solar system may be filled with invisible seas, dark oceans, locked oceans, hidden habitats, worlds that look dead from outside, but may be alive inside. Europa is one of the strongest clues that life may not always announce itself. Sometimes it may hide. Sometimes it may wait under kilometers of ice. Sometimes the universe may place its secrets where sunlight cannot reach. But Europa is not friendly. Its surface is deadly. Jupiter blasts it with intense radiation. The temperature is extremely cold. There is no breathable air, no protection, no warmth, no open water. Any life on the surface would likely be destroyed. So if Europa is alive, it must be beneath the ice, protected, buried, separated from space by a frozen ceiling. That makes Europa feel like a locked room in the solar system. We can see the door, we can study the walls, we can measure the cracks. But the real mystery is inside, and we have not opened it yet. What is happening in that ocean right now? Is it empty? Is it salty? Is it moving? Does it touch rock at the bottom? Are there chemicals drifting through the dark water? Are there heat sources hidden on the seafloor? Could something tiny be alive down there? Never seeing Jupiter, never seeing the stars, never knowing Earth exists? This is where Europa becomes more than science. It becomes imagination, not fantasy, not fiction, but the kind of scientific mystery that makes the universe feel larger. On Earth, deep under the ocean, sunlight disappears completely. There is no day, no night, no plants, no sky. And yet, life exists around hydrothermal vents. It survives using chemical energy from the planet itself. That is the key. Life does not always need sunlight directly. It needs energy. It needs chemistry. It needs water. It needs time. Europa may have some of these ingredients, maybe all of them, or maybe not enough. And that uncertainty is what makes the story powerful, because Europa is not a confirmed living world. It is a question, a real moon asking a real scientific question. Can life begin in the dark? Imagine flying toward Jupiter. The giant planet fills the view. Its storms twist across its surface. The great red spot turns like an ancient wound. Radiation surrounds the system like an invisible storm. And then Europa appears, small beside Jupiter, white against black space, covered in scars, frozen on the outside, but maybe not dead inside. Beneath that ice there may be only darkness, only water, only silence, or there may be something alive, something simple, something tiny, something that proves life is not Earth's private miracle. That is why Europa matters. It is not just another moon, it is a frozen world holding one of the greatest possible answers in science. From the outside, Europa looks lifeless, but the universe may not always reveal its secrets from the surface. Sometimes the truth is buried, sometimes the ocean is hidden, and sometimes a moon that should not be alive may be the place where humanity discovers that life was never ours alone. The ocean under the ice. Europa looks frozen, but frozen does not always mean dead. Sometimes ice is not the end of a world. Sometimes ice is the lid, and beneath that lid, something impossible may be moving. To understand Europa, we first have to understand why it should not have liquid water at all. Europa is far from the sun, very far. Sunlight there is weak compared to Earth. The warmth that fills our oceans, drives our weather, and feeds our plants is almost gone by the time it reaches Jupiter. On the surface of Europa, the world is brutally cold. Cold enough that water becomes hard as stone, cold enough that oceans should freeze solid, cold enough that life should seem impossible. And yet, Europa may have an ocean. That is the mystery. How can a frozen moon so far from the sun keep water liquid beneath its surface? The answer is not sunlight, the answer is gravity. Europa orbits Jupiter, and Jupiter's gravity is monstrous. It pulls on Europa constantly. But Europa is not alone. Other large moons also orbit nearby. Io, Ganymede, Callisto. Their gravity tugs on Europa too. This creates a cosmic trap. Europa does not move around Jupiter in a perfectly calm way. Its orbit is slightly stretched. That means sometimes Europa is a little closer to Jupiter, sometimes it is a little farther away. And as it moves, Jupiter's gravity squeezes it, then releases it, squeezes it, then releases it, again and again, for millions of years, for billions of years. This is called tidal heating, and it may be the reason Europa is not frozen all the way through. Imagine bending a metal wire again and again. At first, it feels normal, but if you keep bending it, the wire warms up, motion becomes heat, stress becomes energy. Europa is not a wire, it is an entire moon. But the idea is similar. Jupiter's gravity flexes Europa's interior. That flexing creates heat, and that heat may keep a deep ocean liquid beneath the ice. This is the first shocking truth about Europa. The sun may be too weak to warm it, but Jupiter may be powerful enough to keep it alive. From the outside, Europa looks like a frozen ball, but inside, it may be a world of movement, ice above, ocean below, rock beneath, a hidden sea trapped between two worlds. And this hidden ocean could be enormous. Scientists think Europa's ocean may be tens of kilometers deep, maybe even deeper. Earth's oceans are wide, but not very deep compared to a moon. Europa's ocean may hold more liquid water than all of Earth's oceans combined. Think about that. Earth is the blue planet. Our world is covered in seas. But a small icy moon near Jupiter may contain more water than Earth does. Not visible water, not shining under sunlight, not blue from space, but buried water, dark water, an ocean that has never seen the sky. And that changes everything, because if Europa has that much water, then it is not just an icy moon, it is an ocean world. But the ocean alone is not enough. Water is important, but water by itself does not guarantee life. A frozen moon can have water and still be sterile. A hidden ocean can be deep and still be empty. Life needs more than a place to float. It needs energy. It needs chemistry. It needs a way to build complexity. So the next question becomes even more important. What is happening at the bottom of Europa's ocean? If the ocean touches a rocky seafloor, then water and rock may interact. On Earth, this kind of interaction can create chemical energy. Deep under our oceans, hydrothermal vents release heat and minerals. Around them, life survives without sunlight. Not plants, not photosynthesis, but chemistry. Living systems use chemical reactions as fuel. This is why scientists care so much about Europa's seafloor. Because if Europa has a rocky ocean floor, and if that floor is chemically active, then the hidden ocean may have energy. And energy is the difference between a dead sea and a living one. But Europa keeps its secrets well. We cannot simply look through the ice. We cannot send a submarine tomorrow. We cannot dive into that ocean and switch on a light. The ocean may be buried beneath kilometers of frozen shell, may be thin in some places, may be thick in others, maybe cracked, maybe shifting, maybe slowly recycling surface material downward, or maybe sealed like a vault. And that question matters because the surface of Europa is being constantly hit by Jupiter's radiation. That radiation is dangerous for life on the surface, but it may also create useful chemicals in the ice, oxygen-like compounds, oxidants, molecules that could become energy sources if they reach the ocean. This is where the story becomes strange. The same radiation that makes Europa's surface deadly might help feed life below, but only if the surface and ocean are connected. If the ice shell carries those chemicals downward, Europa's ocean could receive energy from above. If the ocean floor provides chemicals from below, the ocean could be fed from both sides, from the surface and from the deep. That would make Europa more than a hidden ocean. It would make it a chemical engine. But if the ice is too thick, if the ocean is too isolated, if the seafloor is inactive, then Europa may have water, but not enough energy for life. This is why Europa is both exciting and frustrating. It gives us clues, but not answers. The cracks on the surface suggest movement. The young ice suggests change. The magnetic data suggests salty liquid water beneath. The reddish streaks suggest chemistry. But none of this proves life. It only tells us the locked room may contain something important, and humanity has only seen the door. Imagine standing on Europa's surface. Above you, Jupiter fills the sky, huge, striped, terrifying, beautiful. It does not rise like our moon. It dominates the sky like a giant eye. But there is no air to carry sound, no wind, no ocean waves above the ice, only cold silence. Beneath your feet is frozen ground, hard, cracked, ancient. But somewhere far below there may be water, a global sea in total darkness. No sunlight enters it, no stars shine inside it, no sunrise ever touches it. If anything lives there, it lives in a universe without sky, a universe of pressure, salt, chemistry, rock, heat, and darkness. That is what makes Europa's ocean so alien, not because it is impossible, but because it may be possible in a way we never expected. Earth taught us to connect life with light, green plants, blue skies, warm oceans. But Europa asks a deeper question. Can life begin without a sunrise? Can biology survive where the sun is only a distant point? Can a world be alive even if its surface never looks alive? The answer is still unknown, and that unknown is the reason Europa has become one of the greatest targets in modern space science. Because the ocean under the ice may be empty. It may be nothing but dark water beneath a frozen crust, a beautiful but lifeless sea. But it may also be the second cradle of life in our solar system, not on Mars, not on a planet like Earth, but under the ice of a moon. If Europa's ocean is alive, then life is not only a surface story, it is not only a sunlight story, it is not only an Earth story, it is a water story, an energy story, a chemistry story, a story that may be happening right now beneath kilometers of ice. In darkness, humans have never entered. And that leads to the next question. If something is alive down there, where would it hide? Not on the ice, not in the radiation, not under Jupiter's deadly sky, but somewhere deeper, somewhere darker, somewhere close to the energy that could keep life breathing. And to find that place, we have to descend into Europa's hidden ocean, where life could hide. If Europa's ocean is alive, then life is probably not floating everywhere. It may not fill the ocean like fish in Earth's seas. It may not glow beneath the ice. It may not be easy to find at all, because life does not appear just because water exists. Water opens the door, but something else must walk through it. Energy, chemistry, and the right place to survive. That is why the search for life on Europa is not simply a search for water, it is a search for a hidden habitat, a place inside the ocean where chemistry becomes interesting enough and stable enough for life to begin. And the best place to imagine that is not near the ice. It is far below, at the bottom of the ocean in the darkness where water may touch rock. On Earth, the deep ocean was once thought to be almost lifeless, too dark, too cold, too far from sunlight. For a long time, humans believed life depended almost completely on the sun. Plants captured sunlight, animals ate plants, other animals ate those animals. The whole living world seemed to begin with light. But then scientists found something shocking. Deep under Earth's ocean, where sunlight never reaches, life was thriving. Not a little life. Entire ecosystems around hydrothermal vents, black smokers, cracks in the seafloor where hot, mineral-rich water rises from inside Earth. There were worms, crabs, microbes, strange living communities built in total darkness. And they were not surviving because of sunlight. They were surviving because of chemistry. That discovery changed the search for alien life forever, because it proved something powerful. A world does not need sunlight everywhere to be alive. It only needs energy somewhere. And this is why Europa becomes so interesting. If Europa's ocean floor has vents, if warm water rises through cracks in rock, if minerals mix with ocean water, then deep below the ice, there may be energy. Not sunlight, energy. Chemical energy, the kind of energy simple life could use. But here is the problem. We do not know if Europa has active vents. We do not know how much heat reaches the ocean floor. We do not know if the rocky interior is active enough. And that uncertainty is where the mystery begins. Europa gives us hope, but it does not give us proof. Imagine Europa's ocean floor. No sunlight, no sky, no sound of waves, only darkness pressing from every direction. Above, maybe tens of kilometers of water. Above that, kilometers of ice. Above that, Jupiter's radiation sweeping across the surface. If life exists there, it is completely cut off from the universe we know. It would never see a sunrise, never see Jupiter, never see stars, never know that there is a blue planet called Earth, asking questions about it, and yet it might be alive. That thought is almost impossible to ignore, because it means life may not care about beauty. It may not need a sky. It may not need warmth in the way humans understand warmth. It may only need the right chemistry in the right darkness. But life on Europa could also hide closer to the ice shell. Not on the surface. The surface is too harsh. Jupiter's radiation is too intense. The cold is too extreme. Any fragile organism exposed there would likely be destroyed, but within the ice itself there may be pockets, briny channels, salty liquid trapped between ice layers, small hidden lakes, temporary warm regions created by movement and cracking. Europa's ice may not be a simple solid shell, it may be a world inside a world, crushed, fractured, shifted, refrozen, a frozen landscape with secret passages. And if chemicals from the surface can move downward, and ocean water can sometimes move upward, then the ice shell may become a bridge, a place where the surface and ocean exchange material. That exchange matters, because Europa's surface is constantly changed by radiation. Jupiter's radiation breaks molecules apart and creates new chemical compounds. Some of those compounds could be useful for life, dangerous on the surface, but valuable below. If they are carried into the ocean, they could act like fuel. This creates a strange possibility. The same Jupiter that makes Europa's surface deadly may help make its ocean habitable. A monster planet may be both destroyer and provider, but only if Europa's ice allows the chemistry to move. If the ice shell is locked shut, the ocean may be isolated. If it is active and cycling, the ocean may be fed. That is one of the biggest questions. Is Europa sealed, or is it breathing? The cracks on the surface suggest something is happening. The long lines, the broken regions, the strange, chaotic terrain. They look like signs of movement, as if the ice has been pulled apart, shifted, and repaired. Some areas look like giant pieces of ice that broke loose, moved, rotated, and froze into new positions, almost like pack ice on Earth, but on the scale of a moon. This does not prove life, but it suggests Europa is not completely still. And stillness matters. A dead ocean can remain dark forever, but an active ocean can mix. It can transport chemicals, it can bring materials together, it can create gradients, and gradients are important for life. Life feeds on difference, hot and cold, acidic and alkaline, oxidized and reduced, rich and poor. Stillness is not enough. Life needs imbalance, something to use, something to convert, something to push against. That is why the real question is not simply, does Europa have water? The real question is, does Europa have useful energy? Because water without energy is just a dark sea. But water with chemistry becomes possibility. Still, we must be careful. This is where good science matters. Europa may have all the right ingredients and still be sterile. It may have water but too little energy, chemistry but no pathway to life, an ocean but no biological spark. And that would also be important, because if Europa has water, energy, chemistry, and time, but no life, then life may be harder to create than we hoped. Maybe Earth really is rare. Maybe the jump from chemistry to biology is incredibly difficult. Maybe the universe is full of habitable places that remain empty. That possibility is just as haunting. Because Europa can answer two different questions. If it is alive, life may be common. If it is dead, life may be rare. Either answer changes everything. This is why scientists do not need to find aliens with eyes, arms, or intelligence. They only need to find evidence that biology began somewhere else. A chemical pattern, a biological molecule, a strange imbalance in the ocean, a clue that something is using energy in a way non-living chemistry cannot easily explain. Even a microscopic sign would be enough. One cell, one fossil-like trace, one chemical fingerprint. That would be the moment humanity learns Earth is not the only living world. But finding that evidence is extremely difficult. Europa does not make the search easy. It hides its ocean under ice. It orbits inside a dangerous radiation environment. It is far from Earth. And the places most likely to support life may be the hardest places to reach. Deep ocean vents, subsurface lakes, briny ice pockets, chemical boundaries hidden kilometers below the surface. Life, if it exists, may be protected, but also unreachable. That is the cruel beauty of Europa. The ice that protects its ocean from space also protects its secrets from us. Imagine a tiny organism in Europa's ocean. It drifts near a warm vent. It uses chemistry to survive. It divides slowly. It has no eyes, no brain, no awareness. It does not know it is important. It does not know that its existence would rewrite science. It does not know that humans are building spacecraft, telescopes, and theories just to answer whether something like it could exist. To us, it would be a revolution. To it, survival would be everything. That is what makes Europa so emotional. The discovery of life there would not begin with a monster. It would begin with something small, something fragile, something hidden in darkness. And maybe that is how life often begins. Not loudly, not dramatically, not under bright skies, but quietly, in water, near energy, inside darkness, waiting. Europa's ocean may be empty, or it may contain the smallest proof that life belongs to the universe, not just Earth. And right now, the only thing between humanity and that answer is ice. Kilometers of ice, a frozen shell covering one of the greatest mysteries ever found. So the next step is clear. We cannot guess forever. We cannot only imagine the ocean. We need evidence. We need measurements. We need a spacecraft close enough to read Europa's surface like a story. Because if life is hiding there, the clues may already be written in the ice.
The mission to the hidden ocean. Europa may be hiding one of the greatest answers in science. But there is a problem. The answer is buried under ice. Not a thin layer, not a frozen lake surface, but possibly kilometers of ice, covering an ocean no human eye has ever seen. And that makes Europa one of the most frustrating worlds in the solar system, because it gives us clues, but it refuses to open the door. From Earth, Europa is only a small, bright point near Jupiter. Through telescopes, we can study its orbit. We can measure its light. We can observe its surface. But the real mystery is not on the surface. It is below it. And to understand what is hidden there, humanity must go closer, much closer. This is why Europa has become a target for one of the most important space missions of our time, Europa Clipper. A spacecraft built not to land, not to drill, not to swim through the ocean, but to do something just as important, to investigate whether Europa could support life. That difference matters. Europa Clipper is not going there to find aliens directly. It is going there to ask a deeper question. Could aliens exist there at all? That may sound like a small step, but in science, small steps can change history. Before we search for life, we must first understand the world. How thick is the ice? How deep is the ocean? Is the ocean salty? Does the surface contain useful chemicals? Is material moving between the ice and the sea? Are there warm places? Are there plumes? Are there signs that Europa is active inside? Each answer brings us closer to the biggest question. Is Europa only an ocean world, or is it a habitable world? Europa Clipper will not orbit Europa directly for a long time. That would be dangerous. Jupiter's radiation is too intense. A spacecraft staying too close to Europa for too long could be damaged. So the mission uses a smarter path. It orbits Jupiter. Then it repeatedly flies close to Europa, again and again. Each flyby becomes a quick scientific investigation, like a detective passing over a locked house many times, photographing the windows, scanning the walls, measuring the heat, searching for cracks, and trying to understand what is happening inside. Europa Clipper will make dozens of close flybys. Each one will reveal a different part of Europa. Different angles, different lighting, different surface regions, different measurements. And slowly, the frozen moon will become clearer. Not fully open, but less mysterious than before. The spacecraft carries instruments designed to read Europa in many ways. Cameras will capture its surface in high detail. They will study cracks, ridges, chaotic terrain, and strange reddish-brown regions. These images may show where the ice has moved, where it has broken, where fresh material may have reached the surface, where the ocean below may have influenced the world above. But images alone are not enough. A surface can lie. A frozen crack can look dramatic and still tell only part of the story. So Europa Clipper will also use radar. Radar can send signals into the ice. Some of those signals may bounce back from hidden layers, from fractures, from pockets, maybe even from places where the ice changes structure below the surface. This could help scientists understand how thick Europa's ice shell is. And that matters more than almost anything. Because if the ice is extremely thick and sealed, the ocean may be isolated. But if the ice is thinner in places, or broken, or cycling material, then Europa may have pathways between surface and ocean. And pathways are everything. They could carry chemicals downward. They could bring ocean material upward. They could make Europa's frozen shell not just a barrier, but a bridge. Another instrument will study Europa's composition. It will ask what the surface is made of. Water ice is obvious, but what else is there? Salts? Sulfur compounds? Organic molecules? Chemical traces that hint at ocean material. If Europa's ocean sometimes leaks into the ice, or if surface materials are pushed downward, then the chemistry of the surface may contain clues from the hidden sea. Europa's ice may be like a message written from below, a message frozen into the surface, waiting for a spacecraft to read it. The mission will also study Europa's gravity and magnetic environment. This sounds less dramatic than searching for life, but it may be one of the most important parts. Because gravity can reveal how mass is arranged inside a world. Magnetic measurements can reveal whether a salty ocean is present beneath the ice. A salty ocean can conduct electricity. And as Europa moves through Jupiter's magnetic field, that ocean can create an induced magnetic signal. In simple words, Europa's hidden ocean may leave an invisible fingerprint in space.
And Europa Clipper will try to measure it. That is what makes this mission so powerful. It is not only taking pictures, it is listening for the moon's hidden structure, reading its chemistry, feeling its gravity, studying its ice, searching for signs that the ocean and surface are connected. But there is one possible clue that would be especially exciting: plumes, water vapor erupting from Europa into space. Saturn's moon Enceladus does this. It sprays material from its hidden ocean outward, like a cosmic fountain. Spacecraft can fly through that material and study it without drilling. If Europa also has plumes, that would be extraordinary, because the ocean might be sending samples into space. A hidden sea offering tiny fragments of itself. But Europa's plumes are uncertain. They may exist, they may be rare, they may be weak, they may appear only sometimes, and this uncertainty creates suspense, because if Europa Clipper flies through a plume, even once, it could taste the chemistry of the hidden ocean, not literally with a mouth, but with scientific instruments. It could detect particles, molecules, salts, maybe organic compounds, maybe clues about the ocean's habitability. Not proof of life, but a step closer. That is how the search works. Not one magical moment, not one alien creature appearing on camera, but clues, layer after layer, measurement after measurement, a pattern slowly emerging from the darkness, and each clue must be treated carefully, because Europa is not a movie. It is science. Organic molecules do not automatically mean life. Water does not automatically mean life. Energy does not automatically mean life. Even a strange chemical pattern must be tested against non-living explanations. Good science is not about believing the most exciting answer. It is about asking what the evidence actually proves. And that is what makes Europa Clipper important. It will not give humanity fantasy. It will give humanity evidence. For decades, Europa has been a question. Now, finally, we are sending something to ask that question up close. Imagine the spacecraft arriving in the Jupiter system. After years of travel, it enters the realm of the giant planet. Jupiter fills space ahead. Its clouds move in massive bands. Its storms are larger than worlds. Radiation surrounds it like an invisible ocean of danger. And somewhere in that dangerous kingdom, Europa moves silently. Small, white, cracked, still hiding its ocean, Europa Clipper approaches, not to conquer it, not to land and plant a flag, but to listen, to measure, to search for the signs of a world that may be more alive than it looks. During each flyby, the spacecraft races past Europa. For a short time, the moon fills its instruments. The surface becomes detailed. The cracks become landscapes.
The ice becomes data. Then the spacecraft moves away again, back into the dark, carrying information that may take years to fully understand. That is the emotional beauty of this mission. Humanity cannot yet break through Europa's ice. We cannot yet send a submarine into its ocean. We cannot yet touch the possible habitat directly. But we can send a machine across hundreds of millions of kilometers to circle Jupiter, to survive radiation, to pass again and again over a frozen moon, and ask whether life could exist there. That alone is astonishing. A species born on one ocean world has built a spacecraft to investigate another ocean world hidden beneath ice. And if Europa Clipper finds that Europa has water, chemistry, energy, and connection between surface and ocean, then the next mission may become unavoidable. A lander, a drill, a cryobot melting downward through ice, a probe descending into the dark sea. One day, perhaps humanity will not only fly above Europa, one day we may enter it. But for now, the first step is to understand, to map the ice, to read the chemistry, to search for plumes, to measure the ocean's hidden fingerprint. Because the answer may already be there, not written in words, not waiting on the surface, but hidden in cracks, in salts, in magnetic signals, in frozen scars, in the strange, broken skin of a moon that refuses to look dead. Europa Clipper may not find life, but it may tell us whether Europa is a place where life could begin. And if the answer is yes, then the next question becomes impossible to ignore. If Europa can support life, what happens if that life is actually there?